The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Welcome back to another great episode of our Best Practices webinar with 7Signal. If you could, please let us know where you're joining from. I see a lot of you have joined early today. If you are working from home, if you're in the office. The past couple weeks, I have been in the office, but today I am actually from my apartment in downtown Cleveland, and we are joined yet again by our co-host, Jim Vada, in Cincinnati. How are you today, Jim?
I'm good. Good to be here. Thanks, Kelsey.
Awesome. And I hear we might have some all across Ohio. We have a lot of bad weather today, so we'll be on our toes for if we lose any connectivity or connection here. So stay tuned. All right.
Yeah, good reminder. Let me go ahead and turn on my hotspot now, just in case.
Be prepared. Awesome. While he's doing that, I see a lot of you dropping in here where you're joining from. We have, let's see, Roman joining us from Chicago. Welcome back. We have John joining us from Norway. Thanks so much for tuning in, working from home. We have, let's see here, we have Roy from Nebraska joining us. Thank you, Roy. And a couple other people dropping it in there. We have Alan joining us from Santa Cruz. Thank you, Alan. So please keep dropping in where you're joining us from, and we will circle back later as we get started here. So we are 7Signal, the leader in wireless experience monitoring, and we will go a little bit more into depth as we move forward as to what that means and what our mission is as 7Signal. So we have a great topic here today, understanding Bluetooth, low energy, cellular, and Zigbee, and how they affect Wi-Fi. And as I said, we are joined by Jim Vada, who's a CWNE number 183 and Director of Global Wi-Fi Solutions here at 7Signal. And I am Kelsey Rizzuto, the Marketing Specialist, really excited to dive into this topic and see what it entails. A couple of announcements before we begin. For those of you who have joined us recently, these will all sound familiar, but we do partner with CWNP for every single one of our webinars. So if you're pursuing a certification, you are eligible for credits by watching these weekly webinars. So if you need a certificate, just drop a message in the chat here or send us an email and we can send that over to you. Also, for those of you on the line, some of you may be subscribed to our 7Signal newsletter, which we send out every 2 weeks. So some of you may have received that in your inbox today. But with that, we do send out some relevant content, webinar invites, surveys, such as the one to the right here, just to kind of gauge what's going on in the Wi-Fi community and connect with all things Wi-Fi. So we'll go ahead and drop a link in the chat here later on if you'd like to subscribe to that newsletter, and stay tuned. Moving forward here, we do put on a product tour every single Friday at 12 noon Eastern, go.7signal.com/tour. And again, we'll go ahead and drop that registration link in the chat there if you want to join us this week. But we don't go too into depth with any kind of demo on these weekly webinars on Wednesdays, but I will read off just a few exciting updates from us. So we have some exciting updates in regard to the release of Mobileye for iGel Linux and extended Linux OS coverage. And we recently announced about a month ago the release of a portable Sapphire Eye sensor. So a lot of exciting things going on. If you haven't recently joined us for a product tour, go ahead and register so you can stay up to date with all things 7Signal. Additionally, we do post all of our archived webinars to our YouTube channel at 7Signal. So today's broadcast will be up there later this afternoon, so you can go check it out and check out some of our previous archived webinars as well. Few more announcements. We do also post all of our slides from our presentations to our Twitter account. So go ahead and give us a follow at 7Signal, and those presentation slides will be up there later today. But if you don't have a Twitter account, you're not on there, no problem. If you still want access to those slides, you can send us a message, and you all should receive a follow-up email with access to that as well. And another great reason to follow us on Twitter is we give away a ton of 7Signal merchandise to those who follow us and to those who engage with trivia questions. So I'm going to go ahead and read last week's lucky winners. We had Matthew Burge and Chris Durgan. So congratulations to you two. You should receive some prizes in the mail soon. And to the rest of you on the line, stay tuned for, I think we have 2 trivia questions today. So stay tuned for that later on. All right, just a little sneak peek of some ROI data here from recent IDC research. We'll be releasing the white paper for this in the coming weeks. So just wanted to give you a little sneak peek of this and stay tuned for some more exciting updates here. And one last update, again, if you've joined us recently, this will sound familiar, but really proud that we have been recently featured in the Gartner 2020 Market Guide for Digital Experience Monitoring. We've been recognized as a representative vendor for Mobileye, and we will go ahead and drop the link in the chat here as well, so you can access that report if you are interested. All right, on with the show here. So a background on 7Signal. We were established in 2007 in Helsinki, Finland, and we are now located in Cleveland, Ohio. We are really proud of the 1 billion data points that we're analyzing daily and the 5 million devices that we're monitoring daily. We have over 200 customers, over 30 partners, and 14 patents, which means that the technology you see from 7Signal, you're only going to see from 7Signal. Lastly, we are certified in over 40 countries and remain GDPR compliant, which means that we take data and privacy incredibly seriously for all of our users across the globe. As I said, we are the leader in wireless experience monitoring, and we're here because the digital experience matters. And when usually it's negatively impacted, it bubbles up to some top 7 Wi-Fi problems, which we'll cover here in just a second. But what we're able to do is provide full visibility into the end user experience through an outside-in approach with our suite of Mobileye and Sapphire. We are also completely AP and device agnostic, which means that the tools and technologies you already have installed, we are incredibly complementary with those. So as I said, when the digital experience is negatively impacted, it's usually due to one of these top 7 Wi-Fi problems, such as congestion, coverage loss, co-channel and radio interference, roaming, and more. And how we're able to detect those kinds of problems is by running active and passive tests on the edge of the network, looking for things like throughput, packet loss, latency and jitter, adapter and driver issues, and more. So to give you some more insight and perspective as to what makes us so different, if you look at your typical enterprise LAN infrastructure here on the right, you've got those great tools and technologies that I mentioned before, such as Riverbed, Cisco, Aruba, and more. But what we're able to do is pick up where they leave off, giving you full visibility into the user experience from the edge of the network with Mobileye. Mobileye can ultimately be installed on any mobile device, such as your mobile phones, your laptops, your Zebra scanners, your workstation on wheels, and more. And it can ultimately be, Mobileye can be installed on any Mac OS, Linux, Android, or Windows device as well. And to complement that, we also have Sapphire, which are the software-enabled hardware sensors for service level quality and RF visibility, giving you a full perspective, full scope as to what is occurring in your wireless network environment. Taking it one step further here, that typical enterprise LAN infrastructure that you had in the office, it's not really being utilized as much anymore with a lot of us working from home. So we need access and insight into those external home networks, which Mobileye is able to do by giving you visibility into the user experience and your connectivity from your home, from your multi-tenant apartment, from a condo, wherever you are working from, we're able to give you that insight and perspective as well outside of the office. And as I've said many, countless times here, work from home is here to stay. And some of us are home full time. Some of us are there a couple days a week, a couple days at home. But either way, having a Wi-Fi connection at home is not just nice to have while you're working from home. It's mission critical. It's still important to stay connected to your work and to your team. And so with Mobileye, we're able to provide that insight and reliability. Okay, on with the show. I mentioned before we do a lot of trivia here, so I'm going to launch 2 polls that Jim provided for us today. And we're going to do this first one here now. All right, Jim, can you see this question up there?
Yep, sure can.
Okay, what is the new 6 gigahertz band designated for the FCC? All right, let's see. A lot of you dropping in answers quickly here.
Mm-hmm.
There we go. All right, I'm going to give it one more second here, and I'm going to close this poll. All right, how did we
Yeah,
do, Jim?
not so great actually. So
Really?
interestingly, all the talk and marketing and even FCC itself has spoken primarily about Wi-Fi being a user of the 6 gigahertz band. But the 6 gigahertz band is unlicensed spectrum. So it's not designated for Wi-Fi or ultra wideband or 5G. It's actually designated for any wireless protocol that follows the FCC's rules for using it. So the last answer is the correct one.
All right, thank you to all of you who participated. And we're going to go ahead and launch a second poll here that Jim provided. Let's see if people do a little bit better on this one. We have, what channels does Bluetooth use for advertising? And I see a lot of you dropping in your answers now. Give it a couple more seconds here. And we are going to go ahead and close this poll. All right, what about this one, Jim?
I see we've got a lot to learn about non-Wi-Fi protocols. So 1, 6, and 11 are channels used, or our channel is the channel numbering scheme that Wi-Fi uses. Bluetooth Low Energy uses the 2.4 gigahertz band, but it breaks it up into 40 channels, and it uses channels 37, 38, and 39 for advertising. Good.
All right.
We've got an audience that's ready to absorb some new information today.
Awesome. That's great to hear. Thanks to all of you for participating here. So we are going to go ahead and move forward, and I will go and pass the controls over to Jim here so he can get started with this presentation.
Okay. We'll share this screen and move some things out of the way, and we can go. Okay, so today we're talking about BLE, Zigbee, Cellular, and other users of the unlicensed spectrum that Wi-Fi uses. So this is a slide we'll come back to. I think it's a really important graphic. But what we're looking at here are the 4 bands where unlicensed access is currently permitted. The sub 1 gigahertz band, that's what S1G stands for. That's where our 800 and 900 megahertz protocols operate. The 2.4 gigahertz band we're all very familiar with. 3.5 gigahertz is new for unlicensed or lightly licensed usage. That's the CBRS band here in the US. And then the 5 gigahertz band, that higher frequency band where there's more spectrum available, and generally Wi-Fi is able to perform a little bit better. But what we're showing you here are all the different wireless protocols that operate in these bands. So if you look at the 2.4 gigahertz band, of course, Wi-Fi has been there for 20 years, but Bluetooth and Zigbee, which are very popular and growing wireless protocols, operate there as well. So does Thread and 6LoWPAN, and others that aren't even on here. I just tried to limit it to those that are maybe the most common. So it's important to know in the enterprise where more and more non-Wi-Fi solutions are coming in into the RF, where they overlap in terms of spectrum, and plan usage of that spectrum so they're not interfering with each other. So let's first talk about the licensed spectrum technologies that are there in the enterprise. Of course, we're talking about cellular technologies, 2G, 3G, 4G, and now 5G. And these are using bands that are licensed spectrum bands, so we don't need to worry about them interfering with Wi-Fi. They usually come via a DAS, for instance, in the enterprise. And there's also historically been some very large enterprises, like in the oil and gas industry, for example, that have deployed private cellular networks licensed spectrum, very similar to what the big mobile network operators will do. But doing that is very expensive, and so that's kind of seen limited deployment. When we're talking about cellular, we talk about the generations, 2G through 5G, and each of those generations encompasses a different set of technologies. So for a long time, particularly here in the US, some cellular carriers were GSM carriers, like T-Mobile and AT&T, and some were CDMA, like Sprint and Verizon. And those are incompatible technologies. That's why if you bought a GSM phone, it only worked on AT&T or T-Mobile. You couldn't take it to Verizon. But as the technologies have developed, when 4G came out, all the major carriers agreed to standardize on LTE, which is an evolution actually of the GSM spec. And as 5G has come out, the spec that meets 5G is actually just called 5G NR, New Radio. So to learn more about those cellular technologies that cellular carriers use, check out the 3GPP at their website, where you can learn more and actually look at those specifications as well. And although cellular uses different bands than Wi-Fi, it can cause interference, particularly in the 2.4 gigahertz band. Here's an example of an interference source that we discovered at one of our customer sites. And what it was actually a harmonic from one of the cellular transmitters that had some sideband noise, and that harmonic was right in the middle of the 2.4 gigahertz band, causing interference. So that's something to be aware of if you have a DAS or a DAS project going on. Now, some APs will have shielding and filtering specifically designed to cancel out those cellular transmissions. So that'd be something to check with your AP vendor about before embarking on bringing a DAS into the enterprise. But that's most of what's going on in the licensed space. The unlicensed space is where a lot of innovation has happened, and that's where in the enterprise we're seeing Bluetooth everywhere. We're seeing Zigbee more and more. Of course, Wi-Fi has been there forever as our primary unlicensed access technology. Cellular is growing in the unlicensed space, and now ultra-wideband. Since Apple has included an ultra-wideband chipset in, I believe it was the iPhone 11, a lot of interest in that and some of its capabilities, and a lot more that's not on this list. So let's talk about Bluetooth. So Bluetooth is probably the most pervasive non-Wi-Fi wireless protocol you'll encounter in the enterprise. And that's because the smartphones that everyone's carrying around, employees and guests are all carrying them around, now have Bluetooth radios, and the Bluetooth low energy radios are constantly advertising on those channels we talked about, 37, 38, and 39. And Bluetooth uses the same 2.4 gigahertz band as Wi-Fi, and it will use the entire band because it's a frequency hopping technology. It doesn't sit on one channel. It actually moves from channel to channel to channel across the band in order to avoid interference and noise. Bluetooth is based on the 802.15.1 standard from the IEEE, which is now owned by the Bluetooth Special Interest Group. And you can check them out at bluetooth.com to learn more about that. One of the notable features that was introduced in Bluetooth 1.2 is the adaptive frequency hopping feature. So that where Bluetooth tries to avoid Wi-Fi and other transmitters in the band as much as possible. One thing to keep in mind, though, is that if you're using the whole band for Wi-Fi already, 1, 6, and 11, there isn't a lot of room for Bluetooth to operate. So it's you know, there's only so much spectrum. So what we still see, and this is a spectrum analysis graph showing historical spectrum data from one of our own Sapphire Eyes. We still see things like this pretty regularly in the enterprise. So that sawtooth pattern that you see in the line graph, that's Bluetooth. And you can see it pretty much, at least in the background, kind of across the whole band, even though we can see an access point operating on channel 1 there. And there may be one there on channel 6 too, but the Bluetooth is so loud it's hard to tell. But if you look at a spectrogram, that kind of washboard appearance across the band is where you'll see Bluetooth data transfer occurring. And then on the far edges of the band, again, the 2.4 gigahertz band, and right there around 24, 26 megahertz is where you'll see the advertising channels, which tend to be kind of pretty constant transmitters. So again, if you open up a spectrogram and or a spectrum analysis tool in the enterprise, when people are around, you're very likely to see BLE using the same spectrum that you're using for Wi-Fi. Zigbee. So this is a technology that's more aligned with the Internet of Things. It's gaining popularity because it's very low cost, and the sensors themselves can achieve really long battery life, like years long, which makes it very attractive for IoT projects. Particularly if you have thousands of sensors, and you need to consider the operating cost of replacing batteries periodically. So gaining in popularity, the Phi and Mac of Zigbee come from 802.15.4, and then there's this application framework that's built on top of that the Zigbee Alliance provides. So one of the things that's interesting about IoT protocols, a lot of them use the exact same Phi and Mac, which is 802.15.4. What they're actually specifying is the application layer interface and the data structures and what the application actually looks like. That's what Zigbee does on top of 802.15.4. So that's different from Wi-Fi, where in Wi-Fi we've got 802.11 and its payload can be anything. It could be an IP packet or something else. As long as it comes in an Ethernet frame, whatever's inside of it, Wi-Fi will happily just dump onto the wire on the other end. It's really abstracted away from the other layers of the OSI model. Zigbee and other IoT protocols based on 802.15.4 are not like that. They really do specify the higher layer operation of the protocol. So that's an important difference. Again, Zigbee is in the 2.4 gigahertz band, and it divides it up into 16 channels and 3 megahertz channel width. ZigbeeAlliance.org is where you can find out more about them. But to look at the channelization that Zigbee uses and compare that to Wi-Fi. Wi-Fi, we use channels 1, 6, and 11 and 2.4 gigahertz. Those are the non-overlapping channels we can use without causing adjacent channel interference. And if we look at the Zigbee channels on top of that, you can see there are a few opportunities for Zigbee and Wi-Fi to coexist without causing interference. So channels 15, 20, and 25 kind of fit in between the spectral mask of Wi-Fi, and 26 in particular has a little bit more of a guard band apart from channel 11 and Wi-Fi to give us more space. Zigbee doesn't do frequency hopping. It stays on the channel that it's operating on. So this is a great opportunity if there's a Zigbee project going on to coordinate the usage of the spectrum between the two systems that are coexisting. And again, if we look at our own Sapphire Eye, the spectrum analyzer, here's an example of Zigbee and Bluetooth occurring. Now here you can see the Bluetooth. It's not as busy as we saw before, although those advertising channels, those really narrow band transmitters on the very edge are much busier, and they're at 24, 25 as well, kind of constantly transmitting, which is more typical of what we see. And then there's occasional wideband Bluetooth interference is what I usually call it, because we are usually most concerned with Wi-Fi performance, but they're just using the band that they can use as well. So yeah, that's more typical. You see it advertising all the time and then occasionally transmitting data. But we also have here as an example of Zigbee operating on the Zigbee channels 19 and 20. And that is a really busy Zigbee network, and it's stepping all over channel 6, the for Wi-Fi. So, you know, we do have some spectrum up here, channel 25 and 26, you know, on the far right of the graph for Zigbee that those would be better off using. It'd be better off for the Wi-Fi network and for the Zigbee network if they were using non-overlapping spectrum. So again, you know, get on top of all those wireless projects going on in the enterprise, even if they're not Wi-Fi, to make sure the spectrum is being shared, you know, in the best possible way. So let's talk about cellular in the enterprise a little bit more. So, you know, most often this comes in the form of a DAS system where a cellular carrier, a mobile network operator, is using their own licensed spectrum in the enterprise to get better coverage and capacity, and you know, areas like hospitals that tend to be very large and not have great coverage from outside transmitters. But over the last few years, we've seen cellular start to take advantage of those unlicensed bands that we use Wi-Fi for. Right? Unlicensed is not limited to Wi-Fi. anybody that follows the FCC's rules in the US or whatever your local spectrum regulators rules are can use it for different protocols, and that even includes cellular carriers. So that started with a few different flavors of LTE to get access to the 5 gigahertz band in particular. The first one that came out was called LTE-U, and it uses the 5 gigahertz band, and it doesn't have a listen before talk protocol. So this is very, very disruptive to Wi-Fi, because LTE-U will come in and just start transmitting, won't even listen to see if anybody's there or if you have an access point there, or it's just going to start transmitting. This was really controversial and caused a couple of really large companies to complain to the FCC about it. The Wi-Fi Alliance, Google, New York City were unhappy about LTE-U and what Verizon and T-Mobile in particular had planned for it. So next came LAA, Licensed Assisted Access, which just like LTE-U uses the 5 gigahertz band, but it does add a listen before talk protocol. It's not the same as EDCA in Wi-Fi, but at least there's an attempt to check and see if the spectrum's available before the cellular radio starts to use it. And then there's a protocol called Multifire, which hasn't gained a lot of ground, but it was for private LTE, not carrier LTE in the unlicensed band. And what's gained a lot of interest, particularly this year, is CBRS. CBRS is a special band we'll talk more about down the road here, but it's in the 3.5 gigahertz band, so it's not going to interfere with Wi-Fi, and because it's not in an unlicensed band that Wi-Fi uses, it doesn't have a listen before talk protocol, which actually makes the LTE performance better if we can just transmit without worrying about contention. And it's better for Wi-Fi because we're using separate spectrum. And then 5G. 5G is coming into the enterprise, particularly industrial IoT applications that need very low latency and guaranteed bandwidth are looking very closely at 5G for that kind of solution. One more unlicensed technology to talk about that's gained significant interest is ultra-wideband. Ultra-wideband has been around for a long time. The Y Media Alliance started in 2002, which makes it almost as old as Wi-Fi, to develop ultra-wideband. And this technology, the use case, has always been around RTLS, location services with better accuracy than BLE. So think of, if you think of like the manufacturing use case, RTLS, the marketing talks about it being pallet level location, not just what room you're in or what area in, but what pallet is that ultra wideband radio sitting on. So more accurate. And it's gained a lot of interest since Apple included it in the iPhone 11, like I mentioned before. Apple's using it today for directional awareness and with AirDrop. So if you want to AirDrop a file to someone else with an iPhone in a room full of iPhones, and you're pointing your iPhone at that person, it will use ultra wideband to filter the list of AirDrop recipients, so you only see those phones that are kind of in the direction you're pointing. But there are a lot more use cases for ultra wideband, like unlocking the doors of cars, for instance. which we'll see coming soon as well. Ultra wideband, also based on the Phi Mac of 802.15.4. It uses a huge swath of spectrum from 3 to 10 gigahertz, but it uses it in a unique way that's different from everything else that we've talked about. The channel widths are 500 megahertz or greater, which is incredible. That's like the whole 5 gigahertz band. But the transmit power is really, really, really low. So low that most of the time it's below the noise floor from the perspective of a Wi-Fi transmitter. So it tends to coexist very well with other protocols, despite using a huge amount of spectrum. And the Y Media Alliance is where it got started. It's kind of reformed under the Ultra Wideband Alliance, and you can check them out at their website too. But a very cool technology. So again, just coming back to this, I want to re-emphasize this point. These are all and we didn't talk about all of them, but these are all protocols that are showing up in the enterprise. And if your focus is entirely on Wi-Fi, and you're not interested in what OT is doing, what facilities is doing, what biomed might be doing, they're doing wireless projects and they're using the same spectrum. So you need to start thinking of yourself not just as a wireless networking engineer for IT that does Wi-Fi, but as sort of an RF coordinator for the enterprise who's aware of all the different users of the unlicensed spectrum that's available and is helping to make sure that everybody's playing nice together, and getting out ahead of those projects and getting involved in wireless projects to make sure that mistakes aren't made that could lead to performance problems for Wi-Fi and new systems that use other protocols as well. And so a couple new things on the horizon we'll talk about too. CBRS, 5G NR, and the 6 gigahertz band. So CBRS, a lot of excitement around CBRS, and I think there's a lot of very tangible, realistic use cases here. CBRS is a spectrum band. It's actually not a wireless protocol, but the protocol that will take advantage of it first is LTE, that cellular protocol. And the CBRS band is a new part of the spectrum here that we can access here in the United States, and other regulators around the world are looking at similar spectrum sharing systems where we can get fully unlicensed access to the band, or we can get a priority access license, that's a PAL license, and there are existing incumbents that are already using the band that have access to it above all else. So that creates this 3-tier system of licensing. And I think it complements Wi-Fi really well because LTE offers really low latency and great mobility, and it gives you an opportunity to think about what are those most mission critical wireless applications that maybe I want to use this nice clean new spectrum for, and leave all the bulk guest Wi-Fi and file transfers and all the other stuff in the existing bands. That's our bulk high throughput best effort band. And what are the mission critical things that really could benefit from having their own spectrum, maybe be a little bit more, I don't want to say deterministic, but more a better chance of having low latency and clean spectrum. In a hospital, that might be a wireless cart. In a stadium, that might be the handhelds that cashiers are using to run credit cards. We don't want to use the same spectrum as somebody uploading an Instagram video. it would be nice to use something else. So that's the idea there. And what's cool about it is, though the sort of spectrum sharing between the unlicensed general authorized access enterprises, the PAL licensees, and the incumbents is actually centrally managed. So when you fire up a CBRS access point, it will go and check with a centralized database and say, hey, what channels can I use? That's called the SAS system. The SAS will respond and say, you can use any of these 3 or 4 channels because they are incumbent free and there's no PAL users there. And then you've got channels to use that no one else nearby will be using. So really, really cool technology there, and there'll be more and more interest as that goes on. 5G new radio. So 5G really has built-in support for unlicensed bands, including the new 6 gigahertz band. This is called the 5G NRU spec. It's not really just an enhancement of the 4G LTE spec. It's pretty new with some very lofty goals. Much lower latency, deterministic application performance. We'll see it operating in the CBRS band as those solutions mature. But 5G, if you followed the marketing and the spin around it, the hype has just been incredible. I mean, people talk about it like we're going to reshape the whole world because of 5G. It actually reminds me a little bit of when the Segway came out. People talked about how we would rebuild our cities around this new form of transportation. I don't know if anybody's as old as me, you'll remember all the hype around that. And it never came to pass. But the Segway is pretty cool, and I think 5G is pretty cool. It's just, we need to be more realistic about our expectations for it. But certainly more and more we'll see 5G solutions coming into the enterprise, I think. And then, the other big new thing is the 6 gigahertz band, which is not a Wi-Fi band. It is an unlicensed band. Here in the US, the FCC has made 1,200 megahertz of unlicensed spectrum available. We're seeing other countries follow suit with big parts of the band available as well. That's 50, actually more than 50. It's 59 20 megahertz wide channels for Wi-Fi. Just an incredible amount of spectrum. And like we mentioned, 5G and ultra wideband already have native support for the 6 gigahertz band too. But there's so much spectrum here that if you're planning the spectrum usage carefully, there's room for everybody, really. If you want to do 5G as well as Wi-Fi and 6 gigahertz band, there's plenty of spectrum available here. Now, one of the nice things about the 6 gigahertz band in the US is that your typical access point, which the FCC calls low power indoors, that's an AP that's designed for indoor use, and it's got integrated antennas like a typical omnidirectional AP. Doesn't have to do any incumbent detection. There's no checking in to see what channels can be used. There's no DFS problems like 5 gigahertz has. It can just use the band without any of that. So that's really exciting too. And so the Wi-Fi Alliance has a branded Wi-Fi 6, which is 802.11ax, in the 6 gigahertz band as Wi-Fi 6E. And we're seeing Wi-Fi 6E products hit the market already. Intel just announced the AX210 chip adapter, which is their first Wi-Fi 6E wireless adapter, and we'll see more things coming out in the consumer space as well this winter. So just a couple of key takeaways. Understand the spectrum usage of all these protocols, even the non-wireless protocols, because they're, there's a lot of potential for problems to occur when they're overlapping, but there's also potential for them to coexist peacefully. Use the right protocol for the right application. I don't think that it's a matter of, is 5G going to win? Is Wi-Fi going to win? Is something in CBRS going to win? Are these just low-cost IoT protocols going to win? They fit different use cases, and sometimes one protocol is a better choice than another. But I would say, more and more we'll see things that Wi-Fi maybe just isn't the best solution for, and that's why we're seeing these other protocols enter into the enterprise. So CWNP, which the Certified Wireless Network Professional, which has a great certification track for Wi-Fi, has a new certification track for a lot of these non-Wi-Fi protocols, particularly around IoT protocols, and that's the CWSA. I believe it's now the CW ISA, the I for IoT, and they've got a couple certifications around that, which I highly recommend as a great way to get started here. All right, Kelsey, I think with that we can maybe do a few Q&As.
Awesome. Thank you, Jim. Yeah, I think we have time for about 1 or 2 questions here. Thanks to everyone who's dropping them in the questions panel. Our first question here is, how does the new CBRS at 3.5 gigahertz relate to the old Citizens Band radio service at 11 megahertz?
Wow, I love that. It's totally unrelated, except for having the same name. So I think that's must be a ham radio guide there. So 73s to you. Good question.
All right, thank you there. Our next question here is a little bit longer, and this is there a 6 gigahertz band wireless network interface controller that supports monitor mode and packet injection for 802.11ax? If not, what methods would you recommend for capturing 802.11ax traffic?
It's too early to really know that. I think Intel's the first one with a adapter that might support that. I don't know if that AX210 adapter is even shipping yet. Yeah, it's early, and we're still waiting to see those solutions come out. The second part of that was, what methods would you recommend for capturing AX traffic? Guest on here before, Germund, who did a great talk on airtime utilization and OFDMA. Check out his blog, because he's got some different ways. I think his last blog in particular that showed how to do some capturing of 802.11ax traffic, but definitely another area of a lot of interest and more to come there. So I'm interested in those solutions too.
All right, thank you, Jim. I think we have time for maybe one more question. Let's see here. Are you seeing any deployments of 11AH with silicon from new vendors?
Oh, 11AH. Yeah, so that is 802.11ah is branded Wi-Fi Halo, which is in the sub 1 gigahertz band. No, haven't seen any movement there. I think there was a product that came to the market a year or two ago, but It's not something that's gained a lot of traction yet.
All right, thank you, Jim, and thank you to everyone who dropped a question in there. That concludes today's webinar. So thank you to all of you for giving us 45 minutes out of your workday to really dive into this topic. And thank you to Jim for being a great host and a great presenter, as always.
Thanks, everybody.
Thanks, everyone. Have a good rest of your day. Bye.